Okay, I'm going to go on to part 2 of U1A2. Now, I will not have to do this very often where I have to do a part 1 and part 2. There are a lot of thoughts in here, and they're going back to grade 10, which might provoke a little bit of anxiety for some people because they are packing a lot in here. One of the things they're talking about is balancing of reactions. This is what I'd probably spend the most time on. What I would do is I would go on the internet and look up simple balancing reaction worksheets. Once again, I'd look up simple balancing of reaction worksheets. I am not going to give you difficult ones on tests. I'm going to try and make them fairly straightforward, but I want you to try and master this. In the first one, we have a chemical reaction, Na plus Cl2 gives NaCl. Now, what we can't do is we can't change subscripts when we're balancing. We can only change the numbers out front. If we change a subscript, we change the chemical we have. So if we look at the Na, we've got one Na here, and we've got one Na here. So far, so good. Here we have two Cls, and over here we only have one. So to get a reaction to work optimally, it must be balanced. It'll work if it's not balanced, but it works better if it is. Two Cl's there, put a 2 out front. Remember our rule, that 2 goes with the Na and with the Cl, so we now have 2 Cl's there. Here's what I always say, whenever you balance something, balance or go back and check what it's attached to. So we balance the Cl, it's against the Na. We've got two Nas, now we only have one here, we have 2. Watch this part of the video a couple of times, please. I'm going to do a couple more examples. If you look up balancing reactions and you try and do some balancing, and there's many methods out there to balance, but if you try a couple, or if you get stuck, you don't understand something, take a picture of the question you don't understand and fire me a question and I can work through one with you. Now, usually in life, we attack the simplest things first. I try and attack the more complicated things first when I'm balancing. This looks complicated. I got an odd number and an even number. So what I usually do here is I say, what's my lowest common multiple? Or 2 times 3, what is it? It's 6. So I take my odd number and even number and I multiply them together. So 6 is going to be my target I'm looking for. How do I get 6 H's here? 2 times 3 is 6. Remember, when we have a coefficient and we have a subscript, we multiply them. How do I get 6 here? 3 times 2 is 6. Since I balanced this, it's going to change the amount of n's I have. I have 2 n's here, 2 n's here. Now, on the test, if you don't change anything, put a 1 in there and it won't take any marks off. Now, I go back over the test and I hand mark them anyways, but it is proper to put a number in there. Okay, I'm going to look for something complicated here. I've got a 3 and I've got a 2. 3 times 2 is 6, so I need my chlorines to multiply out to 6. I'll put a 3 here. 3 times 2 is 6. I'll put a 2 here. 2 times 3 is 6. I have 3 mg's on this side. I have 3 mg's on this side. I've got 2 ALs on this side. I've got 2 ALs on this side. 2 times 3 is 6 BRs. 3 times 2 is 6 BRs. Remember, how do you know when you've got a new element? If you have a capital letter, you have an element. When you come to your next capital, you have another element. Folks, the only balancing questions I'm going to ask you are more of the straightforward type of balancing. Try to find a couple of sheets on this and work on this. 4 types of reactions. I'm going to give 5 patterns. Please just write down the patterns and make notes on the patterns and you should be fine here. There are 30-something different types of reactions in chemistry. These 5 here are major types. So these ones here are very important in chemistry. The first type of reaction is an addition reaction. An addition reaction usually has an element plus another element. How can we recognize an element? An element only has one type of capital letter in it, and it adds up to give a molecule. Now, your big indicator that you have an addition reaction is there are no plus signs on the right-hand side. See how there's a plus sign over here on the reactant side? There's no plus signs over there. Generally, it's an element gives a molecule. Now, a decomposition is the opposite. The NaCl, the molecule, is breaking down into the two elements. So it's a molecule breaking down into an element and an element. Once again, how do you know when you've got a decomposition? There are no plus signs on the left-hand side. Now, another type of reaction is a single displacement. In this one, you have an element plus you have a molecule. Once again, you know a molecule, you've got two or more types of capital letters together there. And what happens is that PB wants that Cl pretty badly, and it's tougher, so it kicks the Ca out, and they change places. This is a single displacement reaction. How do you know when you have a single displacement reaction? There will be plus signs on both the reactant and the product side, and there will be a single element and a molecule on the reactant side, a single element and a molecule on the product side. Just look for these patterns. That's all you have to do here. A double displacement has two molecules in it. So what happens here is the two trade places again. So it's a lot like the single displacement, but in a single displacement you have an element and a molecule. Here you have a molecule and a molecule. And once again, how do you recognize you have a molecule? You have more than one type of capital letter there, more than one type here. You'll have plus signs on both sides of the reactants and products, and you'll have two molecules. Folks, follow these simple rules and you're going to be fine. Now, this one here is just ever so slightly trickier, but I'm going to give you two clues whenever you have a combustion reaction. A combustion reaction will always end in CO2 and H2O. So you'll have carbon dioxide and water. Every once in a while, they'll always throw carbon in on top of that. But if you see CO2 and H2O on the right-hand side, it's a good indication that you have a combustion reaction. Also, on the reactant side, you'll have some type of carbon-containing material, plus you'll have O2. So another example of a carbon-containing material is ethane, C2H6. If you have a carbon-containing material and oxygen on the reactant side, carbon dioxide and water on the product side, you will have a combustion reaction. Write down those rules. Put them aside. You shouldn't have to do anything more with types of reactions, but definitely go back and practice some balancing. There's some great simple worksheets out there that also have answers. So when you do your search for worksheets, you can also ask the question, simple balancing problem, type in PDF. That'll help you get a good worksheet too, and write in with answers. That'll get you your best worksheets.